3.3, we're back into graphing. My friend is back here as a prop. We're graphing system of inequalities. System of inequalities is the same thing as system of equations. We have two inequalities that have an x and a y. We get to graph them, shade, and whatever that they share together, it's going to be our solution. We're going to go ahead and look into this together. The first equation, y greater than or equal to negative 3x minus 1. The first thing I want you to remember, this is going to be a continuous line. This is going to be a dotted. Why? This is just less than. Okay, this is just one-on-one graphing. Look at the first one. My y-intercept is negative 1. My slope is negative 3 over 1. So I'm going 1, 2, 3 down and 1 over. It's a continuous line. I completely missed the dot. I'm doing my best. And I need the numbers that are greater or equal to that. I'm going to try to use colors. Hopefully it's going to work. Greater than on top of the line. I'm going to look from left to right. I don't know if you can see this red. I'm praying you can. But this is where the numbers are greater than, right? Now, I'm going to graph my second line. My second line says my y-intercept is positive 2, 1, 2. My slope is 1 over 1, 1 and 1. It's a dotted line, right? It's going to come kind of like this. And now I'm supposed to shade underneath it. I'm going to use blue for it. This is less than. I'm shading underneath the line. Let me see if this works at all. No, it's not working. I mean, it's working if I shade it in here. But as soon as I put it on top of something else, it doesn't work. Let me try the green. If I shade it underneath it, it's going to be right about here. And if you look at it, you're going to notice that this area right here in between this and this is where they overlap. When you do it with your pencil, it's going to make sense. But wherever they overlap, that is your solution. This was a system of two equations. Let's try a system that has now 3 equations instead of 2 and see how that works. Let me go ahead and erase this really well. Here we go. Here's my parameters for this. I need my x to be greater or equal to 0, my y to be greater or equal to 0, and then 4x plus 3y has to be less than or equal to 24. These ones are easy to graph. I don't even need the negative numbers, right? Because I already know I'm staying in the positive realm. How do I know this? Because x has to be greater than 0, so all of this is shaded, and y has to be greater than 0, all of this is shaded. The only one that I actually need to graph is this one. This is a standard form. If x is 0, then y is 3y equals 24, y equals 8. If y is 0, we've already done this many times, so I'm expecting you to know how to do this. 4x equals 24, my x is 6. So I need my x to be 6, my y to be 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. My line is continuous. I have less than or equal to. Here it is. And I need to know where to shade. Well, the easiest way to find out is to pick a point. We already know we have the 0, 0 point. Let's try that. What if x is 0 and y is 0? Well, this becomes 0 plus 0 has to be less than or equal to 24. Yes, it is correct. So I'm shading in here. And this is what my shading is. Why do we only shade one? Because we're looking for all the numbers greater than 0 for x, which means all of this should be shaded. All of this is shaded, so they go on top of each other, and this comes on top of it, so only this part is the one that matters in this case, right? We got that done, and now we're going to look at a word problem, and you're going to have to do this quite a bit in your homework and learn how to set them up to where you can graph them and then find solutions. I'm going to actually read this problem, which I normally don't do. We are on page 158, and it says a person theoretical maximum heart rate is 220 minus x, where x is the person age in years. So here's what you're looking at. Your first inequality, 20 less than or equal to x less than or equal to 65. So we're looking at an adult, and we have this equation that we know of, okay? That's the age. It's between 20 and 65. When a person exercises, it's recommended that the person strive for a heart rate that is at least 70% of the maximum and at most 85% of the maximum. You're making a posture for health class. Write and graph a system of linear inequalities and describe the information given. So let's think about this for a second. First of all, a real life problem. X greater or equal to 0, y greater or equal to 0. We like that a lot, right? We need this because this is a real life problem. So here's my graph that I struggle with drawing a straight line every single time. Those are the two things that we really know. We know that, actually we know that x is greater than 20 because we're looking for the adults, right? What else do we know about x? Is in between 60, well actually I don't need to write this at all because I already wrote it down, I'm sorry. X in between 20 and 65, we have that. Y has to be greater or equal to 0, correct? We're in a real life problem, we have to have that down. Not only that, but my heart rate should be greater than or equal to 0.70, 75%, we can write as 0.70, of the maximum heartbeat, which is 220 minus x, right? I also know that this has to be less than or equal to, it has to be less than 85% of that. So it's 0.85, parenthesis 220 minus x, right? And here's what we did in class and we played with the calculator a lot. The one thing we want to graph is this x because we really, really care about it, okay? So I'm going to do this by 20, 40, 60, 80, and I'm looking at 65, which is right here. So as long as I am in between these, my first shading is my x, right? Here it is. I know that my x has to be in between these two lines because they tell me. Now we're going to have to graph our y's, and here's the beauty of it. We don't necessarily have to graph this by hand if we don't want to. Believe it or not, we can use a calculator, and we did this in class. Let's go ahead and remember how we do this. First of all, please check that your plot is off. Let's clear this again. Second, y, my plot is on. I need to hit enter, move it over, make it off, hit enter, second quit. My plot is off. Y equals. And if you remember, once we clear this, I showed you that if you move your arrow right there, you can determine what you're looking for. My first is greater than. So I'm going to hit enter until I get to that. Hold on. I skipped it. Sorry. Give me a second. Here we are. That's the greater than. It has to be up there. And I'm going to say, okay, that's good. I'm going to come out. And now I'm going to tell you what I want. I want 0.70 times 220 minus x, and I'm going to close my parentheses. That's my first equation. Let's go ahead and do the second equation. We come down. Again, we move over here. We hit enter until now we're looking for less than. I'm going to go boom, boom, greater. Oh, less than. It's pointing down. I like that. I'm going to come out. And I'm going to have 0.85 parentheses 220 minus x. I'm going to close my parentheses again. Here it is. And now all I have to do is graph it and see what we get. I don't remember what my window is right now, so we're going to have to play with our windows once this graphs to the best of its abilities. Mine is done. We're going to hit on window. Mine was terrible. My x minimum is 20. My x maximum is 60. Well, let's do x minimum 10 and x maximum 65. And then for my y's, I know it's going to be a big number. I'm going to make my y minimum, I don't know, 220. That would be, well, not really. Let's do 150. And my y maximum, I'm going to make it 200. Well, my y minimum, let's make it 100. Right? 10, 65. How do I know the 10 and the 60? I shouldn't have 65. I should have 70 there so I can see my equation. 10 and 65, I know what I'm looking for, and these are my two lines. And now I'm going to hit graph. And here is my wonderful graph that I'm looking for. And when you see it overlapping, you're going to notice that I have a place where it overlaps, right? So now I can go ahead and look at those x and y's. If you need to know how much where do you start, you have to move your little dot. right? We're going to move it a little dot until my x becomes 0. I'm going to make it, or 10, whatever my x is. And I'm going to go up and find, I can't find my dot anymore, guys. Oh, here it is. And I'm going to find out that my y starts at 148-ish, kind of, about right here. And it kind of goes like this. And whatever it is that goes on top of it is my solution, right? There about it. That's our solution to our equation. How would we do this? The best way would have been y is greater than or equal to 0.7. If I would do this by hand, 0.7 times 220 gives me 154 minus 0.7x, and y is less than or equal to 0.85 times 220, 187 minus 0.85. X. This would have been really hard to graph, right? This is why we learn how to graph this in the calculator. We just trace it back down and we give the two values that we want over there, and that's our graph situation, okay? We've done this in class. I'm not worried about you. I'm going to let you go ahead and end the video, and happy homework.